Hello, everyone. In the previous video, we learned about black holes through the description of string theory. This is a completely new but also very logical and highly feasible idea. It is worth noting that string theory has eliminated the concept of singularity, thereby eliminating the deadlocks that the theory of relativity has encountered in explaining the nature of black holes. In this video, we will continue to apply string theory to learn about a problem that everyone is familiar with and has heard of, but not everyone believes completely that it was the Big Bang. It must be said that the Big Bang is one of the few theories about the universe that has been built on evidence observed in reality. Of course, to affirm that 100% of the universe was created by the Big Bang is impossible. But to deny the Big Bang is also almost impossible. The biggest contradiction of the Big Bang theory within the framework of the theory of relativity is that the universe originated from an extremely small point that had no area or volume but could contain infinite energy, and mass is indisputable. If we say that the theory of relativity is the best tool that has helped scientists study the universe for centuries, but its weakness is that when everything becomes too small, the equations of the theory of relativity will completely collapse. In those cases, we have to find a way to unify the theory of relativity and just study quantum and string theory. This is the theory that meets that requirement. So, in string theory, how did the universe form? Currently, the application of string theory to cosmological research is still being done. In the early stages, according to the principle of extrapolating backwards in time, in the first moments of the universe, the temperature and energy density were extremely different. Therefore, all analysis and calculations must also require extremely high precision. However, there is an extremely strange thing in the study of snow chains that physicists have pointed out. If you turn back time until the universe is as small as the length of a plank, its temperature will begin to decrease. What is the problem here? Imagine that every dimension in the universe is a circle once you turn back time. The radius of these circles will shrink, and the temperature will start to increase according to the laws of physics. It is generally understood that if we try to compress the universe to be smaller, the temperature will increase continuously. However, with the string theory, everything cannot be compressed to an infinite size. It can only be small to a minimum, which is the Planck length. When the universe is compressed to the Planck size, its temperature will reach a maximum, but will immediately begin to decrease. These are detailed calculations that have been shown by two physicists, Brandenberger and Qumran Vafa. They say that at the very first moment, all the spatial dimensions were equal. They were completely symmetrical, and they were all twisted into a point that fit neatly on the Planck scale. Then, for some reason, an asymmetry appeared that caused three spatial dimensions to uncoil and expand, while all the other dimensions remained tightly wound. What happened and why were only three spatial dimensions released, and the others not. Imagine you had any two particles moving in a straight line in one dimension. If they did not have the same velocity, same fixed speed sooner or later, these two particles will collide to minimize the possibility of collision. We just need to increase the number of dimensions. When the number of dimensions increases to 2, the possibility of collision of these two particles is extremely low because they can move in any direction they want. For example, going up or down, or going around a point. But when the number of dimensions increases to 3, the possibility of collision of these two particles is almost 0. Now,
Let's go back to the Planck universe, when all dimensions are collapsed to the size of the Planck universe, with only one dimension only, the chains to be tightly wound together. And as I said above, when all chains operate in one dimension, their collision is inevitable. That's why, in a crucial moment, there was a chain and an anti-chain that canceled each other out. The unexpected thing is that they accidentally released two dimensions of space, but they were tightening this release like a thorn punctured a balloon. Immediately, almost all the energy released could not be saved. It blew up room 2, the other dimension, plus the one available in the original universe. That's 3 in total, as the universe has evolved into 3 dimensions. The original strings of the Planck universe immediately have more space to move, and as I said above, when the number of dimensions increases to 3, the chance of the strings colliding is almost 0. So there is no further annihilation for this universe to open up the 4th and 5th dimensions. In fact, those dimensions are still tightly wound, and there is a high chance that they will never be opened.